I'm mostly active in Java stuff. But yeah, I like containers a lot. I like Kubernetes too. It sort of has its place. Really need a microservices architecture.
Welcome to UJUG, November 2020. Just a reminder, we don't meet in December, so don't show up here on the third Thursday. That's the only one we don't meet at. But we do have some excellent door prizes that are intended to be Christmas gifts, either for yourself, your spouse, or your kids. Tech Systems has brought us this giant R2-D2, this waffle maker in the shape of a Millennium Falcon, and a sweet little JBL portable speaker. Woo-hoo! Yes, and Lucid has brought these really good little water bottles, and then another sponsor, I forget where they were, had this Seinfeld Lego set, which is kind of a really special thing that I'm excited to give out tonight. And I'm trying to think of the perfect person for that, like a kid who's maybe gotten back into Seinfeld, like a Netflix has discovered recently, something like that. Okay, so let's talk about our sponsors. So thank you to our UJUG sponsors who make all this possible, buy us pizza, buy us equipment, and help make this possible. So course, is where we're at right now. Goldman, and we've got Tech Systems. So who do we have from Tech Systems? We have Kate Conroe from Tech Systems, and then we have a representative from SDG who's going to come up and talk to everyone here and online. So come on up. Would you go ahead and introduce yourself and your role?
Hi, I'm Brady Prestwich. I'm from STG. I'm the new Java practice manager. You may have met Steve Franson before. He's been here, or Brian Hansen was the previous one before Steve. And I'm here to just talk a little bit about STG and maybe a little bit about how things are looking in the Utah market. I know for a lot of us, we're all looking on LinkedIn and being like, wow, another group of 10,000 layoffs for another tech company. But for me right now, I'm actually feeling pretty good about how things are looking in the industry. STG does a lot of consulting work here. So basically what we do is called staff augmentation. That's where you have your regular IT staff supplemented by vendors or contractors. So we bring in vendors and contractors to help people hit, maybe hard deadlines, or if they have a particularly challenging problem that they need specialized help for, we'll send someone in there, help them get it solved. And that's been a really cool business model. And one of the cool things about it is when you have a bunch of layoffs, we make a lot of business. We get a lot of market share because the business side of things realizes we still need things done. It needs to get done now, and we need a bunch of developers. So we come in, we help them out. So right now we are hiring. One of the main ones that we hire a lot of for Java is full stack developers. So if you have a strong Java backend skills with React, Angular, Vue, we could use infinite numbers of you guys. there's a lot of jobs there for people that can do Java, and the market is really strong still for Java here. And let's see, what else was I gonna say? I had some notes.
So STG has a kind of unique way of employing, right?
Yes.
So you want to talk about that a little bit as far
Yes.
as the bench and so forth?
Yes, that was actually what I was going to talk about. Sorry. So some of the cool things about STG is, number one, when you work for STG, you're a full-time salaried employee, but you get what's called straight time. So if you're working more than 40 hours a week, you get paid for each of those hours for the same rate that you would have for your normal 40. So if you don't want to work more than 40, you can just be done at the end of the day. Or if you want to work extra or if you need help, you get paid for it, which is really nice. Or you can take it as PTO and later just take a vacation for that. Or you can buy your PTO back, which is really cool. Another cool thing is when you come off a contract with a lot of contractors, you don't get paid, right? But what we do is we have a bench, or it's called the Dev Center is what we call it. And in the Dev Center, we pay for people to be able to learn their new skills, kind of focus on what areas of the market are changing, and be able to become more marketable so that they can go land a new contract. So it's a really cool business model. I really have loved it at STG. Another cool thing about STG is they really believe in people. People is our product. And so we believe in treating people as people. We believe in making sure you feel like a person. You're not just a number or a statistic or anything like that. So let's see, is there anything else? And there's really good benefits, the same kind of benefits you would normally have at any of the other kind of salary positions that you get. In fact, I just had a baby about 2 months ago, and I didn't end up paying anything for for delivery or labor or anything like that.
Congrats, congratulations.
So that was pretty cool. So it's fun. It's a fun gig. So if any of you guys are interested, I will post my email in the chat. Reach out to me if you have a friend or anyone that here or is watching who's interested in working for STG. I would be happy to get you an interview. We also do things besides Java. So if you have other technologies or other languages that you like, still reach out to me.
Cool.
All right, thank you very much. STG is actually our longest running sponsor since, I think, at the beginning, like in 99. So yeah, over 20 years. So thank you, STG, very much. All right, so let's get on with the presentation. What do you guys think? Let me introduce Jeremy Davis, who is a principal architect?
Chief architect.
Chief architect at Red Hat. And so you also got a Fender Jazzmaster recently out here. And so, yeah, I assume you'll talk about that a great deal, right? That's what brought a lot of people here. I see a lot of jazz fans in the audience. Raise your hand. Very good. All right, so you know, 2 tracks there. Okay, so I'll turn it over to him, and we're going to do a presentation for about 45 minutes, right? And then we're going to do a half hour of more of an active discussion. We're going to go into some other topics, and so have your questions ready for general things. Do you want questions about the presentation during the presentation, or you want them after?
Yeah, feel free to shoot out questions, immediately. If I want to table them, I'll just ask you if we can table them.
Okay.
But yeah, feel free to just interrupt.
Okay, and then as far as general questions, we're going to do kind of this nice discussion at the end, just try to involve everyone, take advantage of having a little smaller group for what it's good for. I'll just turn it over to Jeremy. So please welcome Jeremy Davis from Red Hat.
Thank you. Well, thank you very much. All right, so my name is Jeremy Davis. I've been at Red Hat for 12 years now, which is a long time. We were a much smaller company when I joined. Jason and I have worked together for most of those 12 years, right?
Yeah.
Yeah, off and on anyway, and see each other at conferences pretty regularly. My second time in Salt Lake City, it's really, really nice to be here, surrounded by natural beauty. We have things in Atlanta that we refer to as mountains, but I'm from Atlanta, right? And so we have these things that we call mountains, but they kind of come out here, they're not really mountains. Tonight I'm going to talk about 7 strategies for building majestic monoliths that you can refactor to microservices if you easily refactor to microservices if you need. So first of all, who is building microservices today? Pretty much like everybody, right? So microservices took over, I think like 7 or 8 years ago. The tech world, we all got really, really excited about this because it offered a lot of promise. But they can also be really, really painful, right? Has anybody been bitten by building microservices before, right? Yeah, build a nice distributed monolith. I certainly have. Oh, this is me too. You can still find me on Twitter as long as Twitter exists anyway. And I have not gotten the Mastodon thing going on. I haven't figured out Mastodon yet, but I'll be on Mastodon. So I'm an arrogant programmer, and my email is jeremy.davis@redhat.com. Feel free if you want to follow up on anything. Hit me up on email or Twitter. So, David Hannemeyer Hansen. Anybody use Ruby on Rails before? Very good. I really got into Ruby. I remember at one point in time this video came around, people started sharing this video of Ruby on Rails, and they just scaffolded out this whole application overnight. And I remember having this thought of if I don't learn Ruby, I won't even be able to get a job, next year. And that didn't really happen. But I liked Ruby on Rails. It is really nice and productive. And this guy, David Hannemeyer Hansen, invented the Rails framework. And he wrote this piece, I guess now 6 years ago, called the Majestic Monolith. And in this, he talked about people were asking him, when are you going to refactor Rails? His company has 2 apps, Hey, which is an email app or a messaging app, and Basecamp. And he said people were asking him, when are you going to refactor Basecamp and Hey to be microservices architectures? And his answer was never. He said, I'm never going to do that because we push to production every single Friday. And that's fast enough for us. So we go from a feature request on Monday to production on Friday, and we don't need to move faster than that, and so the pain of microservices is not going to be worth it. We're totally happy with our monolith. And I thought, that's a really great idea. Makes a lot of sense. And then he wrote a follow-up article called The Majestic Monolith Can Become the Citadel. And I really like this concept because what he mentions is there are times when you have a monolith and your monolith really won't scale. We were talking in the elevator on the way up here. One of the first customers I worked with who built or refactored an existing monolith into a microservices architecture didn't do it so they could move faster. They did it because they had scaling problems. And it was a financial company, and they had an application for their quants, the really smart guys that grab all this data and do analysis. And the application had a limited number of users. They had a web app, where the quants could go in and request things. And then they did some file transfers to gather the files. And then they did a lot of processing of the data. And the processing of the data chewed up a lot of resources, right? And so they were running in an application server, right? They were running in JBoss. And they had to scale out a really, really big JBoss environment to handle, this temporary churning of data. And so it made a lot of sense to break that up into 3 different microservices. And in that case, I think it's a great use case. I think it's often overlooked when we talk about microservices. And to me, people are often really negative about a distributed monolith. If you're doing it for reasons of scaling, I kind of think that's okay too. But anyway, what he talks about with the Citadel is the notion of build your monolith so that if you need to pull out a piece like that, if you need to extract, one domain or one part of your monolith, you can do that easily. That was a really great idea. And so I refactored a microservices demo application that I had called the Quarkus Coffee Shop. And let me just go ahead and show you that, running as a monolith first. So I built this out during COVID. There's a couple of coffee shops near my house, and I like to walk down or bike down to them, sit outside and work, especially when the weather's nice. And then when COVID first kicked, you couldn't even be outside near other people, right? Everybody's scared of stuff. So I really missed working in my coffee shops. So I built this coffee shop, and so we've got, like most coffee shops, right? We've got some drinks and some baked goods, right? We've got a little order board here that'll tell you when your order's ready. These are our baristas. And these are actually the guys that created Quarkus. They're not baristas. But I like black coffee, so I'll get a black coffee and place my order here. And when I originally did this, these were all a whole big series of microservices. Right now, it's not. This is a monolith running this application. Taking a while to make that coffee. Ah, great. All right, we crash on the first demo. Whoops, that's why. So that's my refactored outpost. All right, here we go. Come in here, we'll grab a coffee. So now my coffee's in progress, and I'm recording this. We're storing status in a database, and it's fixed by bones. These are Star Trek names. Our baristas are all named for Star Trek characters in the demo. So this isn't a big deal, right? Very easy thing to build into a monolith. So in microservices, there's a lot of stuff going on behind the scenes, even though it's pretty basic application. So if we're going to go about building a Majestic Monolith that we can split up, these are sort of 7 things that I think work out really nicely. Some of these are just generally good coding practices, but I think they really help in terms of designing an application that you can then split up if need be. First and foremost, is domain-driven design and bounded context. Before we get started there, I'll mention technology a little bit. I'm not really going to talk about tech, but Quarkus, Vertex, Kubernetes or OpenShift is in here, Tecton pipeline, stuff like that. If you're not familiar with any of these, just yell. I can jump in any of these if you want, but I'm not really going to focus on any of those. So domain-driven design and bounded context. Is anybody familiar? Do you guys use DDD? Anybody use DDD? Yeah, very good. Anybody else? So this is an old idea, right? This book came out, I think, in 2005, so it's a pretty old idea. But it gained a lot of traction, again, with the advent of microservices. Because a lot of people said or suggested that microservices should match a bounded context. And the idea of a bounded context is that we look at what our application is doing and we treat each section as its own section. So in this application, there's a web section, right? There's a web front end piece that's displaying data, capturing data, marshaling JSON. There's a barista that's making drinks, right? There's a kitchen that's making baked goods. And then there's a counter or an orchestrator that's coordinating all of these events. It's called the counter because one of the things that you do in domain-driven design is you try to work in the language of your business owners. And I think this is really nice. I started my career in the .com days, and so Agile was pretty new, or right after I started working, Agile pops up, right? And Agile's all about delivering more value faster to your business. And I think this is a really good example of this because it's very easy to have syntactical discrepancies or gaps between the way we talk about things and the way our business owners talk about things. And so in this case, inside of a coffee shop, the counter is sort of where everything is orchestrated. Another example, inside the app, if we're out of something, so we're tracking inventory, right? So I'm tracking coffee beans and milk and stuff. If we're out of something, we don't throw an out of ingredient exception, we throw an 86 exception. Because if you've ever worked in a restaurant, you know this, right? When you're out of something in a restaurant, you don't say, I'm out of sugar, you say 86 sugar. No idea why, but you do, right? And so, we use that language from the business, so it would make sense for our business owners. But the idea behind bounded context is your team works inside of your context, and you use the language that makes sense for you. So that's easy enough to do in a microservices, right? Because a team owns a microservice and it owns all of its own stuff. Well, inside of a monolith, the way you can do this is just use your package structure, right? So we've got a coffee shop overarching package, right? But the barista has its own package, counter has its own package, kitchen, web. Now there's a couple of shared things in here, domain and some shared infrastructure. And I think that just makes it easier when you're developing a monolith, but you should be able to split those out. And one of the things in microservices, has anybody read Sam Newman's book, 2 books on microservices? Oh, I'd highly recommend. Sam Newman, he was a ThoughtWorks guy. He's an independent consultant now. He wrote the book, is it Building Microservices? I think it's Building Microservices. Anyway, it's a really fantastic book. And one of the things he talks about is, in terms of reuse, we've always strived for reuse, right? And he says, forget about reuse, copy-paste reuse. If you need to reuse something, copy and paste it. He's like, don't couple your code together. So at this point, we're coupled, but when we pull that out into a monolith, we won't. We'll just rewrite those classes. So there's some other things that you do inside of domain-driven design that I like a lot. The notion, one of the things in domain-driven design is everything goes through what they refer to as an aggregate, and an aggregate are those objects that really mean something to the business. So in this case, our aggregate is, I'll zoom in here so you guys can see this better. Our primary aggregate is going to be the order object. Let me zoom in here. So it's an entity, and the order object contains all the stuff that we talked to. Now, part of the idea, one thing that an aggregate is the aggregate should control all of your database access. This was written in 2005 when it would have been very tempting to sort of write to the line item table by itself. Today we use an ORM framework like Hibernate, so it's not as big a deal. We kind of talk to the top level object anyway. But the other things you want to do is you want to have methods that make sense, like well, apply isn't really a very good method, is it? Add a barista line item, add kitchen line item. Where's some of my other better names? So you want to put logical sounding names that make sense to your business person, like apply ticket up or apply order up, right? So you want to use things that make sense inside of your aggregates. Other things you use are value objects, and value objects should be immutable. And I've got this. Wrote this, so I've got a final class, right? So all these are immutable. They can only be set when the object is constructed. And the idea is you don't pass your aggregates around, right? You leave your aggregates kind of off by themselves, and you pass around an immutable representation. A better way to do this is as a Java record. Anybody use Java records yet?
Jeremy?
Yes.
So we've got a question.
Yeah.
If your slides are available somewhere so people can follow along at home, do you have those posted online somewhere?
No, I don't. Sorry, I should have done that.
Yeah, sorry.
Shoot me, or I'll send you the slides afterwards so you can make them available. Does anybody use Java records yet? That's a class, order in, order up. Yeah, Java records are really nice. Immutable class, this is all you have to do, and you get a method for every one of these, right? It's completely immutable, you instantiate on creation. Great addition to the Java language. In 15, I think, right? 15? I'm on 17. So they're there in 17. All right, so domain-driven design lets you segment your application out so you can work on each piece in its own and then have it ready to pull out. So even though you have some shared pieces, when you do extract it, you can just copy those shared pieces over. All right, so second is APIs first. Now, often when we think about APIs, we think about like a RESTful API, right? Or you can do the same thing for messaging. But remember, we have APIs in Java, right? We have interfaces in Java, and an interface is an API. And a talk that I saw early on, like when I first started working at AJUG, Atlanta Java Users Group, Burke Huffnagel, and he made this presentation also at Java 1 that year, I think, or the year before. Really, really loved this presentation. It really changed the way I thought about the way that I wrote stuff. But one thing you can do is provide an API package, right, with your API to the rest of the application. So the rest of the application will be able to see that you have an API package and then talk only through through those methods. And this is easy enough to do because then if we use package private for the rest of our classes, then you can only see what's implementing that class. And then, of course, if you're using dependency injection, it makes it very easy so you can hide the implementation of the class. So let's go back over here. Close all those. So like I have an API here, interface for order service, right? On order in, on order up, right? That's what my counter cares about. And I've got an implementation, of course, right? And my implementation class, but that's hidden from anything else in the rest of the application. So if if the rest of part of the application wants to talk to this class, it's only going to talk through those public methods. So I can have an API without necessarily having to implement REST. But of course, you can then turn that into a RESTful API or a messaging API as well too. Another thing is like method names should be logical and easy to understand, like apply ticket up. On remake request, right? So you want to use semantic names, not just like, create. Although I just showed you that I have a from method, which is bad, and I should do some refactoring, right? And also, like one of the other things I really like too is follow the principle of least astonishment, right? Make what your method is returning logical and easy to understand. Don't surprise people, right? All right. So number 3, how are we doing on time? Doing okay? All right. All right, so number 3, make data autonomous. In microservices, right, we talk about every microservice should have its own database, right? That's really, really tough. It's very hard in a monolith, but one thing you can do is, like in this application, I've given each of these packages its own schema inside the database. So I've got schemas for barista, coffee shop, kitchen, public schemas. So they're ready to be pulled apart if need be. I'm talking to one database, but if I need to yank it apart, I can. Now, I'm currently reading this book, but I would also highly recommend. It's some ThoughtWorkers, Software Architecture, the Hard Parts. Really, really nice book, and there's a whole section on the first part of the section is how do you break apart, traditional monolithic databases, right? Because if you've ever done, and it's kind of funny, I forgot how awful it is to like work with DBAs and break apart and legacy table structures, right? I was having flashbacks of sleepless nights from reading those chapters. But so if you start off by giving everything its own database, it becomes much easier down the line, right? And the other thing is, like when we used to build MVC apps, right? We used to put like all of our data stuff in the same package. So in this case, don't do that. Keep the data stuff for barista in the barista package, right? And keep the data stuff for. So my barista class has its own barista repository to stick things in the database, right? And it's got an entity. So don't group things functionally, right? Like, so don't worry about putting all your views in one place, putting all of your data access in one place. Store everything by, the bounded context.
I have a question about that.
Yeah.
So you got your database in the monolith, and you're getting ready to break out into the microservices. But in the database, you have these relations between things and references to other tables. What do you do with the data model?
So, okay, really good question. So the question was, when you're in your database, you've got foreign keys, you've got relationships across tables. How do you deal with that when you break things out? So part of the idea of keeping separate schemas is like they're not going to be cross references, right? So it's going to keep its own pieces. One thing that I'm doing here is we'll have so there's two types of data in your application, right? There's operational data that I need to operate on, I need to make things work. And then there's analytical data that I want to expose to the rest of the organization. So in this case, inside my barista item, what I'm storing, so I have operational data. The operational data I'm using is my value object, right? So it's an immutable class. That's what I'm operating on. And that has a person's name. So Jeremy ordered black coffee, right? But I'm not really, the barista is not storing that. The counter stores that Jeremy, who is a loyalty member, bought black coffee because that way I get my points and stuff. But the barista is storing data around what item and then data around how long it took to make it. because what the analytical data that we're going to pull from this particular package, the business wants to know how long it takes to make each particular item. So that's what I'm storing. So if you notice, there's not really a reference to like my actual UUID. I am using a UUID instead of a primary key, so that I could have UUIDs across if I wanted to use them. So that's one approach. But the idea is try to find the seams across that and keep it separate. Like, keep what you need here and what you need here, right? So the counter is the heartbeat of the application. And that's where, like I said, like, if this is a loyalty member, I need to record this person, bought this drink. I should actually probably be recording like the barista's name, right? So then we can find out who's the most efficient barista and give him a bonus, right? But part of this is try not to have like cross joins or cross foreign keys across those schemas. Probably it's easier said than done, right? I mean, this is a demo, right? So obviously that's much easier than in the real world. And yeah, that's what I was saying, that software architecture, the hard parts, it's really, really good stuff on how to go about breaking that apart. And the process they talk about is very similar to kind of this, is you start off with determining your bounded contexts, and then look at your database schema and determine which tables belong to which bounded contexts, and then where, which ones can you break apart and which ones can't you break apart. Because sometimes you're not going to be able to split them apart. Like in a legacy database, right? You may not be able to. Yeah, this is talking about Greenfield, right? So you have more leeway in Greenfield. All right, so avoid bottlenecks. So by bottlenecks, I really mean like performance bottlenecks. And there's a couple of ways. This is, now I got to talk about product a little bit here. So this is reactive programming inside of Quarkus. If you haven't heard of Quarkus before, it's Red Hat's supersonic subatomic Java Kubernetes native runtime. Right? It is really, really fun to code with. It's really fast, and it has a very nice reactive implementation built in. It's based on the Small Rye Mutiny project, and I've monkeyed around with reactive stuff for a long time. I got into reactive Java and reactive extensions for Java. I read the book the Netflix guys did, and the Netflix guys were the lead on that project. I played around with the Spring stuff a little bit. I started my career writing JavaScript, so JavaScript's kind of naturally reactive. I used VertX, which is a project of ours that is works similar to the way that Node.js works. It's very reactive code, but it's not very Java-like. It's actually much more JavaScript-like if you've used VertX. Yeah, I like it a lot, but it's not very normal Java, right? It's very abnormal Java. So I think Mutiny does a really nice job of doing reactive stuff that's pretty readable. But there's a couple of different ways you can do this. So, I mean, under the covers, Quarkus has VertX, and I'll show you guys these projects. So VertX it's called a reactive toolkit for Java, and you can see this kind of syntax, right? It looks a lot more like JavaScript, right, than Java. The guy that wrote it, anybody use JBoss app server before? Yeah, it's JBoss users. So our messaging, our JMS broker that went in around 2010, I guess 2008, 9, was called HornetQ, and HornetQ was written on a non-blocking event loop. Well, right after HornetQ came out, there was another much more famous non-blocking event loop called Node.js, right? So Node.js comes out, runs on a non-blocking event loop, it's super fast. Well, the guy that wrote HornetQ thought, why don't we have this for Java? And so that's where VertX came from. So it's a Java non-blocking event loop. It's really, I like it a lot, but it's kind of squirrely, right, if you're not used to writing that kind of code. And it doesn't have, a dependency injection, a lot of things that we're used to. This, under the covers, this is inside of Quarkus, and I'm using Quarkus for my app. And this is Quarkus. Quarkus is really nice too. If you want to play with it, these apps I've built are in Quarkus. You can go here and just generate an application. These guides are really nice if you want to see any of this stuff. There's a guide for, it's a small core with extensions for all sorts of stuff. And these guides are designed to take about 10 or 15 minutes, and there's a guide for just about anything. So you can come through here in like 10 or 15 minutes and learn how to do just about anything. All right, so the reason I'm getting to that is you can drop down to the under the covers VertX stuff inside of Quarkus. And so what I'm doing here is injecting the event bus inside of VertX. And VertX has not a traditional event bus, but an in-memory event bus. So it can essentially pass messages through classes in memory, but it allows you to decouple your, it allows you to decouple your code. Let me show you what I mean by that. So we have our web front end here. And I've got my coffee shop. So an order is placed, right? So when an order gets placed, actually I'm calling this directly on order in. I've got this send message. I can call event bus publish a web update. Or let's go in here on order in. Whoops, maybe my implementation. So I've got the event bus here. And what I do when an order comes in, I have a place order command. This is a domain-driven design construct. A command tells you that you do something. It's also immutable. And so I call my order from place order command. I really should refactor that to call from place order command, or so that would be a better language. But it gets back an order event result, which just is a container of stuff, right? And it contains a new order, which I then store in the database. And then I get these order updates, and that's what I'm going to send back to the web. But what I do is I publish them on the event bus. So I call this event bus, and I'm just basically passing these by reference in memory to the web updates channel on the event bus. And then my coffee shop API resource is going to grab it and publish it to the, oh, actually, this one's going to grab it. Dashboard endpoint. It's listening on the event bus, and it's listening on web updates, and it's just going to stream anything that happens straight out to the front end over server sent events. So I don't have to communicate back and forth. And the same thing happens with my barista. So in here, I get my barista tickets, and I send them over the event bus, right? So I don't even have knowledge of what class is doing this work, right? And then my barista implementation is consuming that message. So when I go to refactor this to extract a microservice, it's really nice. I can still just listen on there, and then I can listen for the update, right? And I don't have to change any of this code. Now you can't, this is technology specific. So, and this is a really nice piece of technology. What I would recommend as a fallback if you're not using Quarkus is using the API package, right? Because then I'm just calling an API at least, right? And I can swap out my implementation. But this is an extra layer where you can be asynchronous and be reactive. Yep?
So is that consume event annotation, is that part of Quarkus? Is that Quarkus package?
Yeah, so the question was that consume annotation, was that part of Quarkus? So yes, it is part of, and the consume event is, yep, Quarkus Vertex package. So that's the annotation. And if you're used to using, do you guys use Spring or Java, Spring users? Java EE? Mostly Spring, Java ET? Okay. I mean, they're not so different anymore, right? but if you're used to using Spring, I don't think, it's not terribly different, you know, if you're used to using these kind of things. Like, I was using the Hibernate Panache repository, but that's very similar like Spring Data, you know, if you're used to using Spring Data. So it's not a big learning curve. We even have a book for Quarkus for Spring developers. All right, so another piece. Does anybody do continuous delivery? Do you continuous delivery? Some degree. Like how often do you push to prod?
Multiple times a day.
Oh, very nice. Anybody else get even close to that? Yeah, that's really good. Most people I talk to don't or nowhere close to doing that. That's awesome. So what I like, that's why I call it continuous-ish delivery. So because I think it's definitely possible to have the goal of being able to go to prod anytime, right? Because I think we can really pull that off. But actually going to prod like multiple times a day, that's very cool. So the key really is like, you know, have pipelines, have test cases, have pipelines. This is OpenShift and Tecton, but it really doesn't matter what you're using for pipelines. But you have pipelines where you can really do test environments. You know, you can do multiple stages of test, go through test environments. Do you guys have gates for your stuff? Like, does somebody have to approve each?
We have the PR approvals, and then we have the train with its own validation.
Okay. Yeah, very cool. But yeah, so what I think especially for the enterprise, the larger your corporation, the more nervous your executives are going to get about pushing to prod all the time, right? So as I said, so I like to say continuous-ish delivery, but I like to say be ready to go to prod at any point in time, right? So somebody says, okay, we're going to go to prod now. Try to have it so that you're ready to go to prod. And part of that is I also think embracing code quality, right? These kind of tests, Jacoco, PMD, spot bugs. You guys use these things? Use them? Yep, very good. Yeah, I like this stuff. I don't think, I know some people, so I've worked some places where they fail to build, if you don't adhere, super strictly. I think that's kind of annoying. I prefer to use it do it with your code review or look over it yourself, because some of this stuff, you don't really have to, some of this I don't care if getters and setters really get tested. The getters and setters ever break, right? You're generating that stuff anyway, right? So I don't think any of that necessarily matters. Project Mess Detector I think is pretty nice, but I think it's better to use as a guide. I pulled my reports off here. I got those. Here's the ones here's some that I ran. This is the Jacoco report. This isn't looking so good here actually right now. I did delete some stuff on the plane. I was working on the plane, and making some changes mid-air, which is really nice. Wi-Fi on planes, I was texting Jason about this, so Wi-Fi on planes is so much better. When I started working at Red Hat, I had a bash script that I aliased that would go through my M2 repository looking for all the files I managed to corrupt doing a build on a plane, because I did this constantly. And I haven't done that in a long time, I realized. But you can kind of drill in here and see what am I missing here. Equals object, yeah, it's not a big deal, right? But these kind of tools are pretty nice, right? They can really go through and show you what you're using, and I think it's nice to have these as part of your project, and at least keep your eye on them and look through stuff. And there's better stuff in this too. Do I have a PMD? I guess I don't have a PMD. PMD you have to run. It's kind of you have to do that sort of manually. Pardon me. Let me grab a drink of water. And now the interesting stuff. So citadels and outpost. All right, so I really like Kafka as the transport for microservices. REST is great, REST is easy, but you have to do circuit breakers, you do all this stuff, right, because the network's fallible. Kafka is great because you write a message to Kafka, and if the consumer is dead, that's okay, it'll come back alive eventually, and it'll pick up right where it left off, right? So nice. Especially in event-driven stuff, Kafka's really nice because you can, your events are going to play in order. You can replay those. I like Kafka a lot for that reason. Especially once you can use Kafka on the cloud, because when you had to install Kafka on machines, it was kind of horrible. Yeah, you're shaking your head. If you have those scars, yeah, it was kind of awful then. Right? But Kafka in the cloud is pretty nice, right? You just got to click a button, right? What we can do is I've got my barista class. Let's go back here. So my barista package here. That's my barista import, right? My logic is in here. I'm listening for that message, right, to come over the event bus, and then I'm doing all this stuff here. Well, I don't want to do that if I'm going to be in an outpost. So what I'm going to do here is I'm going to check out a different branch. Check out outpost. And now I'm still listening for the order in, but what I'm going to do is I'm going to use an emitter, and this is a Quarkus construct. This is what it takes to send something to a Kafka topic. I'm going to listen for that, and I'm going to send it out to Kafka. So now I can extract this. I can pull a microservice out, so I have no functionality now to kick Quarkus off. Oh, this is my microservice is running here. We'll kill that microservice. Kick that off. And I'll order my black coffee. And now I'm not going to use a Star Trek character name here. I'm going to grab the name of the machine. So this should just be the name of my laptop. Or if I'm on Kube, it would be the name of a container. I hope. Yeah. Ah, all right. Well, I'm sending it back, so I'm returning back my order. So my microservice is picking it up, but I guess I'm not picking it up over here. Is this the right? Yeah. Darn. Let's try it. No, it's not picking it up. All right.
Time to hire a different barista there.
Looks like I need a new barista. Well, it's my counter help here. Orders up. Yeah, all right. I'm not reading off of not reading off of Kafka correctly. Should be in my order service, right? Incoming. Oh well. All right, so I can't. All right, I can set a breakpoint. We'll take a look at the event bus though, so I'll show you that. So my barista here. I'll set a breakpoint here. We'll attach. Why not? Oh, there we go. Attach to both of these. And then I'll let's grab one over here. So this time I'll have a cappuccino. So I'm already in my outpost, so I already grabbed that, and I am so you notice, grab that, pops onto Kafka, pick it up on my outpost, and I'm not reading my message coming back in. But so that's the idea of the outpost, right? Is the outpost, we can extract that, right? I still make the same Kafka call, just instead of processing stuff in line, pops it on a Kafka topic, gets processed now in a microservice, and then gets popped back in. There's another way you can do this too, and I wanted to mention this because I really like the Debezium project, and this is also a really nice way to coordinate across, especially if you're splitting microservices apart. So instead of using messaging, you can write into a database table. Debezium is a project that watches your database for changes. Like I'm using Postgres. In Postgres, it watches the write-ahead log in Postgres. It takes that change and then it pops that onto a Kafka topic. So you can, so if you don't have the ability to send Kafka messages directly, or you're dealing with legacy databases that you want to split apart, right? So you can watch that write. You can and then you can send a message off to another part of the application that way. And so then your outpost can pick this up over Kafka the same way you were as if you were sending the messages directly. All right, that's the end of the presentation. I think I'm 5 minutes over. All right. We should have some time for any more questions or comments or feedback.
Yeah, does anyone in the audience have some questions? Start us off with. I've got some, that I want to ask, but I want you the audience have a chance. Okay, so I recently saw the Twitter comments where a thought leader on this subject gave their opinion on what percent of the world's companies should be on microservices. And I won't tell you what they said. I'm curious what you think that number would be across the whole world.
All right, so can I caveat with that?
No, I'm sorry.
It's got to be. So I think that most companies should be using microservices. I don't think they should look like those diagrams you see from Twitter, like the microservices Death Star. I think it makes a lot of sense to often have a couple of services in an application, right? Or to pull out a couple of pieces. Like I mentioned, start off talking about my customer that built 3 services. So I think that makes a lot of sense. I think it often makes sense in an application. I've built a lot of applications where being able to pull out one part, because that part changes a lot, would have saved us a lot of time. So I'm a big fan of using microservices. I think it's a good way to build things. I think it's, for greenfield, I think it's probably dangerous or more problematic. I think it is easier to build a monolith and then take it apart as need be.
Great. So what do you find are the top reasons, to start breaking things up? Like what are you hearing people saying that, are the top reasons? We all know kind of the classic reasons, but what do you find most common and most compelling?
So I think most people, until fairly recently, most microservices apps were greenfield apps. I think people were starting with microservices, right? I think the most valid reasons, one, performance, which I mentioned, if part of your app is causing you to, scaling headaches because it chews up a lot of memory or resources or whatever, that's a great reason. Another part is if there's a part of the application that needs to change a lot, right? The last application I was leading as a team lead, this is like 12 years ago, right? But the last application I was leading as a team lead, in the enterprise, there was a part, almost all of our releases were to do with this one section of the app. So it would have made a lot more sense, right, if we had, microservices weren't around then, right? Well, they were around, but they weren't a thing, right? If we just had that as a separate service, that would probably save us a lot of time, right? Because especially, you have to regression test everything. And automation, 12 years ago, 13 years ago, automation wasn't what it is today, right? So a release was a lot bigger deal. You release things with your, stay late, order pizza for the team, right? And you do that a lot, especially based around one part of the application, right? And so I think that's a great use case for having, a service there.
What are some of the big mistakes, you see people make as they start breaking things out? They don't think about, or top anti-patterns that you're seeing?
Yeah, so some anti-patterns, often starting, it can be difficult to start with microservices because once you commit to it, you've committed to it, right? So that's one thing I like about starting with a monolith and just package structure. It's a lot easier to massage your domain package when it's in a monolith, right? Once you've got all these microservices that are separate, and because obviously you're passing domain objects around, right? If you're going to do that, what I think and one of my colleagues has a really nice presentation on API-driven development. I would recommend having an API and having some place where you can see your APIs, a catalog of your APIs. Even if you're talking over Kafka, right, you can still have an API, right? So you still have JSON, contracts. So I would think if you're going to start with greenfield, try to publish your APIs so people can see them, right? And so people know if you're especially early days of a project, you're often going to be making changes to your domain model pretty frequently, and I think that's where a lot of pain comes in. Years ago, I think people wanted to just do microservices because they were fun, or they got wrapped around. One of my colleagues has this phrase, "wrapped around the axle," which I love. People get wrapped around the axle around the size of the microservice, and it's not about building something, 100 lines of code. It's irrelevant, right? The bounded context is what you want to make sure you're adhering to.
Very good. So as far as quality, and you mentioned you have one part of the application that changed a lot, and you broke that before. How do you change? What do you think about differently with quality as things? You've got more moving pieces. Can you help people think through that process and what their pipeline is to change?
Yeah, being able to spin up an integration environment, right, is nice and important, right? So when you on a code commit, have a part of your pipeline that do all your unit tests and stuff first, right? So you want to make sure all those pass. Be able to spin up an integration environment. Have some data ready so you can build that environment and run through integration tests, as part of your pipeline.
Very good, very good. All right.
Yeah.
Get the microphone.
Yeah, I just want to know your opinion when you're having repositories for microservices. Are you in favor of monorepos? What's your opinion there?
I don't like monorepos. I like everything to have its own repo. But And I don't know. I mean, like Google uses monorepos, right? So obviously, maybe I'm not smart enough to use a monorepo. But yeah, I think that's just a lot. It's really complex. Even multi-stage, what are the Git repo where you have the refs to the head? I just find that really hard to do. To me, it's just, I'd rather just clone them all or write a script to clone all of them. You know. Yeah, I don't. It's not that hard, right? Git clone's not difficult. So it seems to me like you just end up with it's so much more trouble than have to make sure you're in sync. Yeah.
So earlier you used the term distributed monolith at one point.
Mm-hmm.
So what are some signs that your microservices are actually distributed monolith?
Yeah, you can't deploy them independently.
So deployment speed, one.
No, independent deployment. So like I said, this is also a microservices example, right? And so in the microservices, we have 7 or 8 microservices that make up that coffee shop. You can deploy any one of them on its own. So I can make changes to any one and deploy it. That's a microservices architecture. If I make changes to one and I have to deploy 3 of them, it's not. That's a distributed monolith. Right?
Okay, gotcha. Would you also consider things like downtime or reliability, the coupling between services and what needs to be up to run, the functioning site? Is that as a part of a monolithic nature of a distributed system? Just as an example, like an analytics service might go down, and customers might never know. But if a user service goes down, the site shuts down, right? So it seems like the more interdependency you have, the more monolithic your distributed system is. Or what do you think about that?
Well, so ideally you would want pieces to be able to fail and still maintain the system, right? Like in this case, if the barista or kitchen goes down, it's down, right? If there's a customer loyalty thing, that's okay, that can go down. The inventory thing, that can kind of go down. Like we can not track inventory for a while, and that's okay. So I do think it's important to design things in that way so you can minimize your points of failure. And it is good. It's a good point. Like there's certain parts of your system that can go down. It's okay. And that's one of the bad things in a monolith. If that thing goes haywire, it can pull the whole thing down, right? So microservices obviously offer you an advantage in that respect, right? And that's also one reason I like using Kafka as your transport, because you're still writing messages to Kafka, right? Like if you're doing REST, you're gonna trip a circuit breaker. Right, you're going to be pushing messages. Can't talk to that thing. Hang on, I'm going to stop. And then you have this other cascading failure. You have to deal with that, and you need some sort of process to deal with all these messages that get dropped on the floor. Right. So yeah.
So this is my final question, which is, so I'm a personal fan of Kafka. Used it, loved it, but now it seems like you've introduced a central point of failure to everything that everything was down. Right? Do you see that as a dilemma, or is it so reliable in practice that it's not really a concern?
Yeah, I mean, I think Kafka is pretty reliable. And I mean, it scales out really well, and it's very configurable in terms of like how many replications you have and stuff. So yeah, I think it's really reliable. And at the end of the day, like, I mean, the network's always fallible, right? But it's like, is it better or worse than REST? Yeah, I mean, I think it's better than REST. Is it better or worse than JMS? I mean, it offers some advantages over JMS for microservices. I mean, JMS is great though. You can do tons of stuff with JMS, right? Yeah, Kafka's pretty reliable, I think. At the end of the day, nothing's perfect, right? You got to.
Right. It's all about the trade-offs.
Right. Yeah, that's a really good point. That's one of the points that this book I just mentioned a couple times already. I saw Neil Ford speak, who's the ThoughtWorks guy, and he said he thinks of software architecture as making the best worst decision or the least worst decision, right? Because you're never going to come up with the optimal perfect thing, right? You're just going to make the least bad choice.
Here we go. Another question.
So you mentioned Node and the non-blocking event loop that Node uses.
Mm-hmm.
And that Vertex also has a non-blocking event loop. And I know that the rationale for Node was we have a single-threaded app, JavaScript is single-threaded, and so how can we have asynchronous programming within that single-threaded context? What is the advantage of Vertex offering this non-blocking event loop when you're operating within a concurrent language like Java?
So some of the things under the covers that Vertex does, and they're in a really interesting spot right now. So Vertex would spin up an event loop per core that it had access to. So if you're on a 4-core machine, it would spin up 4 event loops, which is pretty interesting. Now they're noticing in containers that's actually that kind of goes away, right? Because you don't really have access to the actual CPU cores. And so they're going back to a single event loop, or at least when you're running inside of a container, they're going back to a single event loop. But the real advantage is, like, a lot of the things you're doing in system calls, like, you know, let's say I'm making a REST call. Well, that's kind of blocking. I mean, it's blocking by nature, right? But if you do it in an event loop, it doesn't have to be blocking, right? Because you send it off, you have a callback that you wait for, right? So you come back to that. And it allows you to build out especially multiple system calls, you know, pretty quickly. I have a pretty good presentation on that too sometime. Hit me.
All right, so this is a question we ask a lot of our presenters. The challenge a lot of companies have is how to maintain velocity as they grow. And your presentation, you know, addresses, you know, a lot of that. So I want to get your other thoughts on that. What would you, if you're consulting, what would you tell this growing company?
So I think I really think the concept of bounded context and organizing teams around that, and just embracing that it's okay if we have different language for things, or if we deploy different times. So when I was in the enterprise and in large companies, for a while there was a big movement to have like a canonical domain model for the whole organization. Like, which is kind of nuts if you're dealing with like a multinational company, right? And in the book Domain-Driven Design, they have a good example of that. The notion of an invoice is going to mean at least two things to your company, because if you're sending invoices, it means a very different thing than you're the person that pays the invoice, right? So you know you can't really have one canonical domain model. And so I think as a company grows, it's okay, we're going to add a new team, and just remember, we're going to interact with that other team, right? And I also think there's a couple of trends. So there's this big trend right now in organizations, right, that kind of central IT is sort of collapsing a bit into lines of business, right? And lines of business are getting their own power and autonomy. In fact, we were talking earlier just about that a moment.
We're in that situation right now with FedEx.
Yeah, you guys are doing this. Wait, who's the person with the train? Yeah, there you go. We were talking about that, right? You have 50 different organizations, right? And each one wants to do things a little bit different, right? And you want to maintain some coherence, but you want to give people the ability to make their own choices and do their own things. So there's a couple of concepts I really like. One, Nike's talked about this. The Austrian healthcare, government healthcare, did a really good paper I read about this, where you break the company apart, but it's the notion of being like a connected enterprise. And so each line of business, like, they have autonomy, but they expose APIs to the other parts of the organization, and they really take care of those APIs. And like Nike talked about it because they're really moving like the wearables, right? And or wearables and gathering data from that. And there's all these different parts of Nike, right? They make golf clubs and they make shoes, right? And each of these parts of the organization, exposes data that you can then create an entirely new line of business, and they have access to all the pieces they need. There's another really interesting concept I like, and another book I can recommend called Data Mesh by another former thought worker named Jemek Degani, and she's a really great presenter too. She's on YouTube. And the notion of data mesh is that, like what I was talking about with data, you have operational data and analytical data. And you should treat the analytical data as a first-class citizen and expose that out to the rest of the organization, right? So, I might be in the bounded context, one part of the organization, but we treat, and not data scientists like us, like programmers, everyday programmers, right? Java guys. Expose, APIs, expose your data to the rest of the organization and maintain it and treat it as a first-class citizen. Let the rest of the organization know they have a point of contact on your team, where they can work to see your data. So if you do that, you can grow, but you can still maintain your velocity and maintain independence.
Very good, very good. We haven't got any questions on the line yet, so I'm going to sweeten the offer here. The first person to ask a meaningful question from online gets a JetBrains license. So let's bribe it out.
Who uses JetBrains? Everybody, right? Yeah, there you go.
Everybody uses JetBrains. Okay. So I want to step back a level of abstraction here and just give an opportunity for you to talk about what you're excited about in the industry right now.
Okay, well, I just hit on a couple. I think the notion of data mesh is really, really exciting. I've been reading through that book. I actually got about halfway through and then left it on an airplane, so my second copy's on its way. But really, really great book, and I've been digging into that in a bunch of other articles and presentations too. I think it's a really exciting concept. I think this is going to be something that people really embrace the way that we embraced microservices, 7 or 8 years ago. I think that's very exciting. I like Kubernetes in the cloud. I like being able to spin things up really quickly. I think that it offers you a lot of advantage to be able to spin up your entire environment, right? Even if you're doing it like you spin up a new namespace with all my stuff ready to go and just be able to work that way, I think is really nice and exciting. I really just kind of getting my feet wet with serverless stuff. So I think there's a lot of promise there, but I haven't done as much with it. Does anybody do serverless? A lot of serverless? So a bit. What's the, yeah? Well, I'll talk to you guys after. I have a bunch of questions too on serverless.
So you mentioned Kubernetes there. Do you have any quick pro tips? Everyone who uses Kubernetes, what are your hard-won pro tips there?
Ooh, Kubernetes pro tips: learn the Kubernetes CLI, right? Learn kubectl, like, and yeah, get very familiar with kubectl, and get familiar with ways to easily, start and stop, tear down stuff and rebuild it. Helm, learn Helm.
Okay. All right. So, as far as just managing quality in an organization, what organizations do you see to do well? What do they do differently than other organizations?
So failing fast is a big thing. In fact, one other thing that I think is really exciting too, and I think the move to the cloud is pushing this in interesting ways. The move from project thinking to product thinking, right? So traditionally we always thought in terms of projects, right? And often in the enterprise especially, you would get budget, like somebody who has an MBA has some ideas and they want to put those in production, right? And so they have budget and they go to IT and you get a project team assembled and that team lives, they build these features and then they disappear and they go away, right? And then you rinse and repeat. And I think there's a big move now. You see like the no projects, circle with a slash through it. But the notion of we own a product, right? And we're going to continually make this product better. And we're going to think about this in more of a linear fashion instead of just a set time frame. We're just going to always own this product. We're going to work on this product. A couple of things I think are interesting, because one of the things you want to do in product design and development is you want to be able to experiment, right? You need to be able to experiment, right? You need to be able to fail things. And because experiments are going to fail. And so embracing the notion that we're going to experiment, it's okay to experiment, it's okay to fail. But to be okay to fail, you have to be able to fail fast and then recover really quickly, right? So being able to have a discipline around that is really nice. Another piece that I like is product managers like to look. Most advancement is incremental, right? We get little incremental gains, but they always look for the thing they call the 10x, right? Like the iPhone was not a little bit better than a flip phone, right? It was a lot better than a flip phone. And so product managers look for that 10x kind of thinking. And we can do that too, even if we're building internal apps for our own internal customers, right? We can kind of look iteratively for that kind of 10x, breakthrough where we can really do stuff. Now, all those things are kind of fuzzy in the world of, coming from the world of project thinking. And I think the move to the cloud, and Red Hat had a bit of a jump on this, right? Because we didn't sell licenses. We sold like the subscription that was kind of an annual thing anyway. And in the cloud, you pay as you go, right? And so your CFO has to think about this in a different light, right? Because you used to just write a check, right? And you just write this one big check and you were done. And now you kind of think about like, okay, we just kind of pay a little bit now, and we pay more later if we need to. And so I think the enterprise is beginning to, and startups have kind of always done this, right? But the enterprise is beginning to look at things more in terms of we're owning products, we're really going to address our customers, and we're going to take a bigger picture, longer term view of things. I think that's a really big, exciting trend.
Very exciting. All right, so last question. What soft skill do you think is most important for the technologists, and how do you grow that?
Ooh, soft skill is most important. Being an empathetic human being and a nice human being, I think probably not just for a software developer, but for just about anybody, probably, right? We've all known, a friend of mine had a great story about his first day at work somewhere. I'm not going to name any names. But it's on his first day at work, they're in a design session, and a fist fight broke out. Right? Not just an argument, right? Right. And so these guys end up rolling over a sofa, like throwing punches, right? So nobody wants to work in that environment, right? But I think the ability to listen, and this is also a general. What's the book? It's the ancient book, How to Win Friends and Influence People. So it's really a great book. And one of the things that he mentions in there is people like to talk more than they like to listen. And so everybody likes to talk, and people like to be heard. And so if you can hear people, you know, that's a really good skill. People like that, and they'll want to work with you. And you actually have to make yourself do that, because we're always thinking about what we're going to say next, right? But actually, like, try to practice, like, okay, I'm going to actually listen to what somebody else says, and like listen to what your colleagues, you know, opinions, right? Because all we're doing is making the least bad decision, right?
We've got a question from R. Hall, and if you're still here online, send us an email board@ujug.org so that we can ship you your JetBrains license. So I don't have access to your emails from YouTube, unfortunately. Anyway, he asks, what is the best way to influence your organization to start with a monolith and selectively use microservices?
So if you have built microservices, a greenfield microservices application, you probably have some of those scars or paper cuts, right, from having to massage that domain model, having to break it apart. I would say show them the ability. Talk about something. Grab some of my slides if you liked these, or if you felt these were compelling, for sure. Show them, like, hey, we can do this, and there are ways. If we approach it in the right way, we can pull this stuff apart later. It's not that hard to yank apart, you know, as long as you kind of follow, you know, some discipline around building it. Although I know it's more fun to build microservices.
Oh, we have a question. Thank you.
Hey, Jeremy, we've talked a lot about like greenfield development, but a lot of us here have started with legacy applications, and we're kind of in the middle of a project trying to break our monolithic legacy application into microservices. We have taken a lot of these approaches to, we're building what we hope, it's a monolith right now, and that we're deploying it as one, but we're trying to utilize a lot of these principles that you've discussed here. Hopefully we're doing it right, but what do you see out there? What are some good ideas or good patterns, strategies to take an existing legacy application that wasn't a Majestic Monolith, it was an ugly monolith, and to convert that or break that? What are some strategies that maybe you've seen other companies have success with, or maybe even just, this is a failure path, don't go down that?
That is a really good question. And also, like, and I don't mean to say that monoliths are ugly, right? Because I like the notion of Majestic Monolith. And I'll tell you, so sorry, brief anecdote. I talked to these guys once, a team once, and they had a monolith, you know, and it had grown unwieldy, right? It had been around for about 10 years. And they wanted to rewrite it, and you know they were seeming kind of like embarrassed, like, yeah, you know, we did this. Like, well, that's how you did things 10 years ago. You know, there's nothing to be ashamed about. And I started asking them, so how much usage does it get? So I said, well, yeah, it probably does about $2 billion a year goes through the app. So $2 billion a year goes through this app, and it's like 5 guys on this team. And I'm like, you've had this application for 10 years. $20 billion has gone through your application. Like, there's no reason to be embarrassed about the state of your app. Like, come on, you know. So just because something like might look a little gnarly now, you know, that was fine, right? And a lot of this comes from MVC, right? And that was the best practice, right? We used to go to job interviews, and we'd get to diagram the MVC pattern, right? And you had to nose like the back of your hand. And like now we're saying, like, yeah, that was a dumb way to do things, but that's okay, because everybody who was smart was telling us we had to do things that way. So I just wanted a little credit to the fact that, like, hey, just because, you know, we built something 15 years ago doesn't mean it's bad. It was bad. So some of the things you can do to break them apart, there's some. One, you want to look at how tightly coupled is it, right? Look at break your classes apart, or look at your packages, right? And find out how many connections are within the package and outside of the package. Because like one of the things I was doing here was I was suggesting that you have an API, and that's the only way in and out of that package, right? So that makes it easy to break that package apart. Oftentimes in a lot of legacy applications, that's not the case, right? Things get bounced all over the place. You'd want to do some real analysis on that first, because you might want to say, like, yeah, we're not going to break this apart, right? But then look inside and say, okay, well, what are the domains? Because if let's take an MVC application like we would have written with, say, like Spring MVC or Struts or something, right? Or even a JSF app, right? We would have thought view first, right? We create our view, we go to some controller, right, that's going to do some logic, and then we stick stuff in a database, right? And unfortunately, that means our business logic gets spread across all these views, and then all the database code is in a database. But we do have, there's going to be logical boundaries inside of that app, right? So some might be, a customer account, some might be, shipping, right? Whatever, right? So try to figure out what those boundaries are, or what those domains are inside of there. Look at your database, and then look and say, can we match our package structure to these, right? So can we refactor some package names so that I begin to pull these apart, right? And so instead of saying that all my database access is going to be in the dot, persistence package, right? Because I've built plenty of apps like that, right? But can I pull these apart and go from the persistence package to the shipping package? Then look at your database and kind of look at the database tables the same way. Are there certain tables that belong to some of these domains, or are they kind of all over the place, right? Some things are never, will never get moved. I did one contract once at a place, and I remember going to one of the senior guys there, and I said, okay, so like that is this huge database table, right? It's enormous, and like everything was required. So I'm like, okay, I don't even know what all these mean. So I said, well, what does this one mean? So, it's a varchar. I said, well, what goes in it? He said, it's a varchar. You can put anything in it. And I said, well, but it's not no. It's like, yeah, you can put whatever you want. And I was like, okay. And I thought, we might not. This might be bad. Right? In that case, you might not going to break that. You guys have to look like that. But.
We're not that bad.
Yeah.
Thank you.
All right, we have one more question online, and then we will be done.
All right, cool. This is from David M., and he actually wonders the inverse of the last question. When does it make sense to collapse microservices back into a monolith?
I would say if you find that you can't deploy them independently. Like if you've got, let's say you've got like 7 or 8 microservices, and 3 of them always have to be deployed together, put them back into one, right? Because they're not independent. So either there's, maybe you could solve it just by doing some refactoring, but if they really are, like maybe they belong in the same domain, right?
Perfect. All right, that's it for our presentation. Let's give away some prizes. Get it one item. So I've got my fancy random number generator to determine winners, and so let's see, gentleman in the blue there, you have won a prize. So you get to pick the first thing here as far as what you would like. So yes, that's you. Come on up. All right, next winner, number 1, 2. Okay, actually the guy who, let's see, orange vest, there. You are the second person to pick a prize up here. Come on up. So go ahead, you're the first one. All right.
R2D2.
R2D2. There you go. All right, so we've got waffle maker, portable speaker, and Seinfeld Lego set. All right, portable speaker. Okay, so next person is, let's see, gentleman in the back there. Blue shirt, right? You get to pick a prize. So come on up, and then let's see, gentleman right there. Come on up. You got the last one, and then we've got these water bottles. So you got your waffle maker or Seinfeld. You get to choose. His destiny is in your hands as well. So this is a weighty decision. All right. So congratulations. Hope you're a Seinfeld fan. We got the Seinfeld legs. All right. If you want a Lucid water bottle, come up and get it. We've got 6 here. If you've already won a prize, please forego the water bottle. Don't be greedy. And that's it. January, that's Spring Boot. And we'll probably be back here. We'll let you know where it'll be. So please, another round of applause for our presenter. Thank you so much.
Thanks.